where there are three questions which are related to each other. So, plane 5 meters in length is inclined at an angle of 37 degrees as shown above. A block of weight 20 newtons is placed at the top of the plane and allowed to slide down. So the weight is equal to 20 newton. And the first question is easy. The mass of the block is most nearly. It's asking for the mass. It's very easy. And you know the weight is equal mg. So all you have to rearrange for m, which is weight over g, which is 20 over 9.m, equal to 2.04, which is approximately 2 kilograms. The answer is D. Question number 62. A more interesting question. The magnitude of the normal force exerted on the block by the plane is most nearly. It's asking for m. Here I have the figure again and the free body diagram. So here I have the vertical and horizontal component of the weight. Here I have the normal force, and that's all. Here I have my y and x axis, and we apply here. I have alpha, and these two angles are alpha too, because this angle and this angle are 90, this angle and this angle are 90, therefore these are equal, and these equal to this angle because they are alternative angles. So we apply Newton's second law, which is in the y component because we want to calculate n. So we apply, and we have n, because it's in the y direction, positive, minus the gravitational force in the y direction is negative because it's in the opposite side of the y, equal ma, and we know that a equals 0 because the block is standing on the plane. There is no acceleration upward or downward, it's just standing. There is only acceleration downward because it's sliding. Oops, I'm sorry, very sorry. And therefore n equal the gravitational force in the y direction, and the gravitational force in the y direction is given by w multiplied by cosine alpha. All we have to do is just replace the numbers, and we have w multiplied cosine 37, 20 multiplied cosine 37, it's 15.97, approximately 16 newton, and the answer is C. The last question. The work done on the block by the gravitational force during the 5 meter slide down the plane is most nearly. We know work is the work done by the gravitational force is the change in potential energy. There will work equal change in potential energy. Work equal mgh1 minus mgh2. This is h1 here, and this is h2 at the bottom of the plane. So we can factor mg. We left with mg, h1 minus h2, and h1 minus h2 is 3, and mg is the gravitational force, the weight w, which is, these aren't the same w. I'm sorry that I used the same symbol for two different things. This is the weight and that's the work. And w, we can replace mg by the weight, which is 20, and we end up by 20 multiplied by 3, which is 60 joules. I have the answers right here. You can check. 61 is D, 62 C, 63 B.